Hello students, let us continue the session on statistics. In the previous session we had discussed exercise 14.1. Today we shall discuss exercise 14.2. And the first question here is, the following table shows the ages of patients admitted in a hospital during a year. The age groups are given as class interval and the number of patients are the frequencies. Find the mode and the mean of this given data. Compare and interpret the two measures of central tendency. To find out the modal class, let us consider the class interval with the highest frequency. Here the class interval with the highest frequency is 23. So let me mention that to find out modal class, let us consider the class interval with high frequency. Here, greatest frequency is 23. Therefore, modal class will be 35 to 45. So the lower limit of the modal class is 35. And the class width is the class size. It is 10. The frequency of the modal class is 23. Frequency of the class preceding the modal class is 21. Frequency of the class succeeding the modal class is 14. This is F1, this is F2. And we can make use of the formula mode equal to lower limit plus frequency of the modal class minus frequency of the class preceding the modal class, 2 times of frequency of modal class minus frequency of the preceding modal class minus frequency of the succeeding modal class, and this particular thing to be multiplied with h. Let us substitute the value. Upon substituting the value, we get mode as the lower limit is 35 plus the frequency of the modal class is 23, preceding one is 21, divided by 2 times of 23 minus 21 minus the frequency of the succeeding modal class is 14. This has to be multiplied with the class size 10. So we get 35 plus, this becomes 2 multiplied to 10 will be 20 divided by 46 minus 36. Uh, 46 minus 35, it will be 11. So roughly we get it as 35 plus 1.8. So the mode will be equal to 36.8. To find the calculation with respect to mean, we need to follow a table. So first let me mention the class interval, then the respective frequencies, then the mid values, then the product of frequency and the mid values. The class intervals are 5 to 15, 15 to 25, 25 to 35, 35 to 45, 45 to 55, and 55 to 65. The respective frequencies are 6, 11, 21, 23, 14, 5, and sigma Fi, the sum of the frequencies, is 80. In adding, we get it as 80. Mid values or the midpoints are 10, 20, 30, 40, 50, and 60. The products 6 times 10 is 60, 11 times 20 is 220, 21 times 30 is 630, 23 times 40 is 920, and 50 times 14 is 700, 5 times 60 is 300, and we need to add them up. Sigma Fi Xi, we get it as 2830. So the mean is found as sigma Fi Xi divided by sigma Fi, and this will be 2830 divided by 80. 0 will get cancelled and we get 35.7. Mode is 36.8. It represents that the age of maximum number of patients admitted in hospital was 36.8 years, and the mean is 35.37, and this represents that on an average the age of patients admitted to the hospital was 35.37 years. Question number 2. The following data gives an information on observed lifetimes in hours of 225 electrical components. The lifetimes are being mentioned in terms of class interval and frequencies are given. The first thing is we need to identify the modal class. Here 61 is having the maximum frequency, therefore the modal class is 60 to 80. Let me mention that here modal class equal to 60 to 80. So the lower limit of the modal class is 60. Frequency of the modal class is 61. Frequency of the preceding modal class is 52. Frequency of next or succeeding modal class is 38, and the class size is 20. So let us make use of formula. Mode equal to lower limit plus frequency of modal class minus the frequency of preceding modal class, 2 times the frequency of modal class minus frequency of preceding minus frequency of succeeding model class to be multiplied with the class size. Let us substitute the value 60 plus 61 minus 52 upon 2 times 61 minus 52 minus 38 to be multiplied with 20. Therefore, we get it as 60 plus 61 minus 9 is minus 52 is 9 divided by 122 minus 52 minus 38 will become 32, and this has to be multiplied with 20. So roughly we get it as this is divisible by 4 for 5 times, 4 8 times, so plus 45 divided by 8. So 60 plus 5.625, it becomes 65.625, and this particular thing is there in terms of number of hours. Therefore, the modal lifetime of the component is 65.625 hours. Question number 3. The following data gives the distribution of total monthly household expenditure of 200 families in a village. Find the modal monthly expenditure of the families. Also find the mean monthly expenditure. The expenditures and the families are given. We need to find out the mean monthly expenditure and the modal monthly expenditure. First, let us find out the modal monthly expenditure. Let's identify the modal class. Here the maximum frequency is 40, so the modal class is 1500 minus 2000. So not minus 2000. So let me mention the modal class here first. Modal class is 1500 to 2000. The frequency of the modal class is 40. The lower limit of the modal class is 1500. Frequency of the class preceding the modal class is 24. Frequency of the class succeeding the modal class is 33, and the class size is 500. Let us make use of formula mod equal to lower limit plus the frequency of the modal class minus the preceding frequency by 2 times of frequency of modal class minus preceding minus succeeding multiplied to the class size. Substitute the value, we get 1500, which is lower limit, plus within the bracket we need to mention the frequency of the modal class, which is 40, minus the frequency of preceding is 24 by 2 times 40 minus 24 minus the succeeding frequency is 33, should be multiplied with 500. So we get 1500 plus this will become 16. This I'll multiply into 500 divided by 2 times 40 is 80. 80 minus 24 minus 33 will become 23. So we don't get the exact value, approximately we need to find it out. We get 347.83 added to 1500, which is 1847.83. Now we need to calculate the mean. For that, let us follow assumed mean method. Here the class intervals are 1000 to 1500, 1500 to 2000, 2,500, 2,000 to 2,500, 2,500 to 3,000, 3,000 to 3,500, 3,500 to 4,000, 4,000 to 4,500, 4,500 to 5,000, and the respective frequencies Fi are 24, 40, 33, 28, 30, 22, 16 and 7, and we get some of these frequencies are 200 because 200 families they have mentioned. If you look at these values here, they are very huge. Both the mid values and frequencies are huge. So instead of assume mean method, it's better to solve it in step deviation method. So for that, I'll find out the mid value first. 1520, 1750, 2250, 2750, 3250, 3750, 4250, 4750, and the deviation will be xi minus assumed mean. Let me assume that 2750 is the assumed mean. Let me highlight that 2750, I have taken it as a assumed mean. Now, when I subtract 2750 from each one of these mid values, I'll get minus 1500, minus 1000, minus 500, minus 0, positive 500, positive 1000, positive 1500, positive 2000. Now let me divide these deviations by class size. Here the class size is 500. So on dividing we get minus 3, minus 2, minus 1, 0, 1, 2, 3 and the 4. Now I'll find out Fi Ui, the product of frequency and all these values obtained by a step. So we get minus 72, minus 80, minus 33, 0, 30, 44, 48, 28. Let us find out sigma Fi Ui. This will be negative 35. You need to add all the positive values and all the negative values. On further simplification, we get it as negative 35. Therefore, the mean is given by assumed mean plus sigma Fi Ui divided by sigma Fi, and this should be multiplied with the class size h. So assume mean 2750 plus negative 35 divided by sum of frequencies 200 into 500. Two of the zeros will get cancelled. We get 2750 and this becomes negative 87.50. So 2662.50 will be the mean. Therefore, the mean monthly expenditure of the families is rupees 2662.50.